closer to unlocking the biggest cosmic secrets. It may be puzzling to some that we possess the capability to detect exoplanets situated at astronomical distances, with some lying hundreds or even thousands of light years away from us. Yet, there remains a conspicuous absence of evidence for the existence of the elusive Planet 9. For the uninitiated, Planet 9 is a hypothetical massive celestial body that certain scientists believe exists in the outermost regions of our solar system. It is theorized that the planet has a mass of approximately 5 to 10 times that of Earth and possesses an extremely elongated orbit that carries it as far as 20 times the distance of Neptune, the farthest known planet from the Sun. The idea of the existence of Planet 9 came about due to observations of certain objects in the outer reaches of the solar system, such as the trans-Neptunian objects and sednoids that have orbits that cannot be explained by the gravitational influence of the known planets alone. Therefore, scientists propose that a yet-to-be-discovered massive planet may be responsible for these anomalies, exerting its gravity on these objects' motion. If this is true, it would suggest that Planet 9 occupies an extremely elongated, egg-shaped orbit, completing one revolution around the Sun every 10,000 to 20,000 years. To put its orbit in perspective, Neptune orbits at a distance of 2.8 billion miles from the Sun and completes one orbit in a mere 165 years. And orbiting at such a distance from the Sun would render the planet incredibly faint, approximately 6,250,000 times dimmer than Uranus as seen from Earth. Although there are a multitude of asteroids of similar dimness, they are distinguishable due to their rapid motion across the sky. In contrast, Planet 9 would move at a very slow relative velocity to Earth, making it extremely difficult to differentiate it from just another dim star. Sure, one idea is to use super-advanced telescopes like the Kepler telescope to find Planet 9. But telescopes don't work that way. Telescopes detect exoplanets by observing the small eclipses that happen when they pass in front of their star. Planet 9, if it exists at all, won't do that. Scientists would have to find it against the blackness of space by detecting the tiny amount of sunlight it reflects. It's like trying to find a needle in a haystack, but instead, the haystack is in space, and you're given a pea shooter to search with. And to make it even harder, you're doing it while spinning around like a top. That begs the question, how does one go about discovering Planet 9 in the first place? If I were to show you an image like this one and ask, "Can you see a planet here?" you'd probably say, "Yes, that's Earth down there." But other than that, you might not be able to spot it. You may have already guessed what scientists go through. Therefore, it's truly remarkable that early human astronomers were able to differentiate between stars and planets more than 4 millennia ago. utilizing nothing more than careful observation. By meticulously observing the night sky on a regular basis and creating intricately detailed star maps, Babylonian astronomers were able to chart the motions of celestial bodies and determine which were orbiting within our solar system and which remained relatively fixed in place. Stars, being at such great distances, should not appear to move, in contrast to the planets, which lie much closer. Not a bad piece of deduction. But this method of observation, even with today's technology, can only identify planets that lie closer to Earth. Efforts have been made to detect the heat signatures of Planet 9 using infrared telescopes, but thus far, the search has come up empty-handed. Scientists ask themselves a logical question. What kind of object would have enough mass to change the orbits of other celestial bodies, yet not be visible to us? There is an idea that Planet 9 could potentially be mistaken for a primordial black hole, which would exhibit similar effects. Although it's purely hypothetical, as we haven't detected any primordial black hole yet, at the very dawn of the universe, when everything was much denser and hotter, primordial black holes popped in and out of existence within just a second. And depending on when during that second such a black hole was born, its mass could have been as little as 5 to 10 grams or as enormous as 100,000 solar masses. The thing is, if our calculations about an elusive planet's mass are correct, a primordial black hole, a few times the mass of Earth, would only be the size of a grapefruit, or even smaller than a human fist. And if that's the case, we have no chance of finding it with a telescope ever. Let's also remember that black holes are also infamous for their gravitational pull, making them among the most destructive celestial bodies in the known universe, from which even light cannot escape its gravitational effects. But even if a primordial black hole does exist at the edge of the solar system, there is no cause for alarm, as Earth is not in danger. Primordial black holes are too small and weak to cause any significant harm to our planetary system. But what made astronomers come up with the idea of primordial black holes at all? For one thing, it was an inexplicable brightening of stars, as if some massive but almost transparent object was passing in front of them. What's more, these stars not only started to shine brighter for a brief moment, but they also seemed curved, as if you were looking at them through a giant magnifying glass. Furthermore, when scientists created a computer model of a primordial black hole 5 to 10 times as heavy as Earth and with an orbit distant from the Sun, the results were intriguingly similar to the events occurring in the region of the Kuiper Belt. Too much so to be a mere coincidence. And finally, a primordial black hole would explain why hypothetical Planet 9 can't be seen and doesn't produce infrared radiation. There's also a wild theory that Planet 9 could be a brown dwarf, a star that is not massive enough to sustain nuclear fusion in its core and emit light. The ideas and possibilities are endless. Perhaps somewhere, a photograph of Planet 9 already exists. but has simply been misidentified as a star. With so many billions of stars to keep track of, and with Planet Nine's 10,000-year orbit, it would be forgivable if it took a few years to notice that one star was not in exactly the same place it had been when it was last photographed. Those searching for Planet Nine have bet their hopes on a new generation of telescopes, one of which, the Vera Rubin telescope, is currently being built in Chile. As part of the Legacy Survey of Space and Time project, it's scheduled to begin operations in the fall of 2023. This is going to be an 8.4-meter or 27.5 feet telescope with a 3200-megapixel camera on board. The camera, the size of a car, is going to be the largest camera constructed for astronomical purposes. With such a tool, scientists could not only verify if Planet Nine actually exists, but also find roughly 20 terabytes worth of space objects and other phenomena in one night. Just in a year, the observatory will be able to capture more of the cosmos than all the telescopes on Earth ever did combined. This can turn our perception of the universe and our place in it upside down. Or maybe the James Webb Space Telescope, which offers unprecedented details of the infrared region of the cosmos. It's a tedious job. The planet is shrouded in mystery. But despite this, its allure is undeniable, drawing in only those who dare to uncover its secrets. Of course, the ninth planet might not be there at all. And while the jury is still out on what exactly exists out there, we can say for certain that with the advancements we've been making in technology and with the determination of astronomers worldwide, someday we'll hit the final nail in the coffin of this mystery. The question of extraterrestrial life has long been a focal point of discussion when broaching the mysteries of the universe. Despite the tireless efforts to scan the starry expanse for any indication of life beyond our world, what revelations have we achieved thus far? Recently, in 2022, a telescope in China recorded an anomalous signal that exhibited a highly restricted frequency range at 140.604 megahertz, a level of accuracy that is not commonly attained through natural means. The signal triggered a widespread investigation into the origins of this transmission. The source of the signal was quickly postulated to be emanating from the general vicinity of the exoplanet Kepler 438b, which is situated about 470 light-years away from Earth. With a radius just 1.5 times that of Earth, it's well within the class of planets known as super-Earths. Adding to it, its location within the habitable zone of its host star suggests that liquid water could exist on the surface of the planet, providing a potential environment for the emergence and sustenance of life. Therefore, Kepler 438b is a prime candidate for the astrobiology research study of exoplanets as a potential home for alien civilizations. The likely transmission from the planet was intercepted by the 500-meter aperture spherical telescope named Sky Eye, situated in the Guizhou province of southwest China. The telescope is specifically engineered with the objective of search for extraterrestrial intelligence, or SETI, in mind. With a colossal diameter of 1,600 feet or 500 meters, it's no surprise that it's the largest telescope in the world and can boast the capability of capturing 40 billion observations per second. Given the expansive scale and unparalleled sensitivity of the telescope, it was immediately inferred by Chinese authorities that the signal from Kepler 438b was of extraterrestrial origin and represented a manifestation of alien intelligence. China's Ministry of Science and Technology even reported that their astronomers had discovered several instances of potential technological signatures and indications of extraterrestrial civilizations from beyond the Earth. The claims spread like wildfire, disseminating throughout Chinese state-controlled media and the Chinese social media sphere on Weibo before being reported by the international press. But then, all of a sudden, the story disappears. The report is mysteriously expunged without explanation, almost as if it had never existed. Consequently, numerous theories were proposed by an international community of astronomers, with the most prevalent explanation being radio interference. Dr. Wertheimer, a prominent SETI researcher at the University of California, rebutted the claims, asserting that the signals were nothing more than radio pollution generated by earthly sources, rather than conclusive proof of extraterrestrial life. The issue of radio interference has become increasingly pressing. With the exponential increase in electronic devices among the human population, coupled with the ever-growing number of satellites in Earth's orbit, this leads to significant discrepancies in instrument readings, making it imperative to carefully evaluate and filter out these interferences before any conclusions can be drawn. The scenario is not uncommon and has led to a multitude of false positives in the past, leading to the growth of skepticism towards such signals among the scientific community. And it's not just some random scientists. Even the renowned American astrophysicist Dr. Frank Drake, known for his famous Drake equation, has been fooled. Back in 1960, he recorded a weird signal when he had aimed a radio telescope at a pair of stars and believed that he had made a groundbreaking discovery, only to later eventually realize that the signal was a mere stray antenna emission. And in 2019, astronomers in southeastern Australia spotted a signal beamed to Earth from Proxima Centauri, the nearest star system to our Sun, which sits roughly 4.2 light-years away and is believed to be home to at least one potentially habitable planet. The team was conducting a 26-hour-long survey as part of the Breakthrough Listen project, a $100 million effort to find alien transmissions using telescopes globally. They picked up a 5-hour-long flurry of radio waves, and out of the 4 million signals they recorded, only BLC-1 stood out as unusual, both for its length and its peculiar wavelength. The team then eliminated the possibility of interference from satellites or other human-made aircraft, but the ultimate origin of the signal had remained a mystery. until a few years later when the researchers conducted a more thorough examination of their initial data. This time, they discovered that their automated sorting program had previously overlooked several signals that bore a striking resemblance to BLC-1. The BLC-1 and those look-alike signals were components of the same radio source, and that radio source was likely something on the surface of Earth, probably within a few hundred miles of the Australian telescope. Since the signal never reappeared, it's possible that it was emanating from a piece of malfunctioning electronic equipment that had either been deactivated or was undergoing maintenance. The team surmised that the signal's appearance during that 5-hour observation of Proxima Centauri was likely a fortuitous coincidence. Moreover, this is not the first or the second instance of a banal piece of human technology being mistaken for alien hardware. In a similar vein, another famous set of signals, once believed to have originated from extraterrestrial entities detected between 2011 and 2014, were subsequently determined to have been generated by scientists heating up their meals in a microwave. But that's the thing for SETI. It's a tricky business. You've got to sift through a lot of noise to find the real signals. Scientists have always contemplated the possibility of constructing a telescope on the far side of the moon as a means to circumvent the increasing radio pollution on Earth and the interference caused by the satellites in orbit. Right now, it's totally normal to be a little skeptical when you hear about a new alien signal being detected. After all, we've been burned by false alarms before. But that's just how science works. You have to keep an open mind and keep searching, even if it means sifting through a lot of false leads. Who knows? Maybe one day we'll finally find that one smoking gun that proves we're not alone in the universe. A century ago, the sky above was clear of human interference, but the technology to take advantage of it did not exist. Conversely, in a century hence, the sky may be so saturated with human-made noise that this opportunity may no longer be available. The present moment may be a fleeting opportunistic window in which to conduct the search for extraterrestrial intelligence from Earth. In fact, many experts in the field of SETI believe that we are on the cusp of a major breakthrough. With new technologies and advancements in telescope capabilities, we are able to survey more stars and scan for potential signals with greater precision than ever before. This new optimistic mindset for SETI has reinvigorated the search for extraterrestrial life, inspiring renewed optimism in the face of the long-standing conundrum between the profuse possibility of the cosmos and the scarcity of tangible evidence for life beyond our planet. This discrepancy between the vastness and antiquity of the universe and the apparent paucity of intelligent life forms beyond Earth, commonly referred to as the Fermi paradox, has been a source of perplexity for scientists for a considerable period of time. The paradox takes its name from the impromptu lunchtime musings of Nobel Prize-winning physicist Enrico Fermi, who, after contemplating the conundrum, is famously said to have exclaimed, "So, where is everybody?" Scientists believe that not finding aliens is normal, due to the fact that only a fraction of a percent of the 200 million stars in the Milky Way have been surveyed. The detection of extraterrestrial radio signals which is considered as one of the key methodologies in SETI, is a formidable task that requires sophisticated technology and advanced scientific methodology. The task was never expected to be easy. But it's not just about the technology. It's also about the approach. Some scientists, on the other hand, argue that we may need to rethink our methods and consider alternative forms of communication that extraterrestrial civilizations may be using. The possibility also remains that if alien civilizations are sending us, or inadvertently leaking, signals across the vast expanse of the cosmos, they may not be encoded in radio waves, but in ways that our current technology is not yet advanced enough to comprehend. It won't be surprising if our current approach to SETI is misguided. If one examines the history of SETI, the original ideas proposed around 200 years ago were things like building big fires on Earth, or installing some big mirrors that reflect sunlight to the Martians, or even making some mile-long right-angled triangles to show aliens we know about Pythagorean theorem. Nowadays, we look back and say those ideas were naive. So what's to say that 200 years from now, people won't look back at us and ask, why didn't we use tachyons or subspace communication? But for now, we can only work within the constraints of current knowledge and technology available to us. Today, despite the disheartening reality that the signals they have detected have an earthbound origin, SETI astronomers remain steadfast in their belief that humanity is not alone in the universe. With an estimated trillion planets in our galaxy, many similar to Earth in size and composition, the potential for the emergence of intelligent life is high. And they remain optimistic that one day, amidst all of our own radio noise, we may uncover something truly extraordinary. The first contact may not happen within our lifetime, but it's only a matter of time. It is one of the hottest topics among the scientific community. How big is our universe? As we gaze up at the endless expanse of the night sky, we are reminded of our own insignificance in the grand scheme of things. The countless stars twinkling above us serve as a silent reminder that our tiny home planet is just a minuscule speck in the vastness of the universe. A mere glance at the celestial canvas above us is enough to grasp the incomprehensible enormity of the universe, a vastness that stretches far beyond the limits of our imagination. It is a mystery that may never be fully unraveled, a puzzle that could potentially remain unsolved forever. Despite this vastness, the question still toys with human intrigue. If you've ever wondered, where does the universe end? You're not alone. Great physicists, such as the late Stephen Hawking, and many other theoretical scientists have been pondering this question for decades. In 1917, Albert Einstein made a groundbreaking prediction about the expansion of the universe, a theory he initially had doubts about until he saw evidence from Hubble and Humason. His general theory of relativity posited that the very fabric of space was expanding, causing galaxies to move further apart. When a photon is emitted from a distant star, it travels through an ever-expanding universe, adding to the already huge distance it must cover to reach us. But just how vast has the cosmos grown since the Big Bang? Recent precise measurements from the Hubble Space Telescope and other instruments estimate that the universe is 13.8 billion years old. Within this time, a beam of light could have traveled 13.8 billion light years, or approximately 1.3 quadrillion kilometers. However, taking the expansion of the universe into account, the most distant galaxies observed by the Hubble are actually now 46.5 billion light-years away from us in each direction. That is 93 billion light-years from each other. So, is this the true size of the universe? To accurately determine the size of any object, it is crucial to first understand its shape. The actual shape of the universe has been a topic of discussion and debate among researchers, and there still isn't a satisfactory answer. Remember that Einstein's theory of relativity says that space and time can bend and morph. Space could be one of a variety of different shapes. It's hard to imagine this in the 3 dimensions that we know space really is, so let's substitute a 2-dimensional analogy. In flat regions of space-time, objects traveling along parallel paths stay along parallel paths. In positively curved regions of space-time, parallel paths converge, and in negatively curved regions of space-time, parallel paths diverge. But what about space as a whole? If space is positively curved everywhere, then the universe would be shaped like a giant sphere, where if you kept on walking, you could, in principle, end up back where you started. If space is flat everywhere, its shape could be simple, extending out straight to infinity. And if space is negatively curved everywhere, things would fly instead of falling. So, which is it? One method of determining the curvature of an object is by assessing the angles within its triangles. If the object is flat, the sum of the angles will equate to 180 degrees. Conversely, if the object is curved, the angles will result in a sum greater or lesser than 180 degrees, depending upon the nature of its curvature. Cosmologists using the Planck Observatory have done the equivalent of measuring our universe's triangles by looking at a picture of the early universe and studying the spatial relationship between different points on that picture. So what did Planck and other experiments find? It turns out that measurements show the universe to pretty much be flat, within 0.4% margin of error. So can we conclude that space is flat and infinite? Physics is an experimental science. When we say that the Earth is flat, what we mean is that the measurement is consistent with being flat. But that also means that the measurement is consistent with a tiny bit of curvature. For example, if we're at the beach on the ocean and look at the horizon, it surely looks flat. But, in spite of the claims of some people, the Earth most certainly isn't flat. It's a sphere. So we have to keep this in mind. What appears to be flat can indeed be curved. And when we measure Earth, we can only say that it appears to be flat. That is true for space as well. Space appears to be flat. But what if space is an extremely large sphere, so big that it looks flat, just like the Earth can look flat? Well, in that case, space is not infinite. It has a finite size. During a careful analysis, using the maximum possible curvature allowed by the best measurements, astronomers found that the universe can be no smaller than 250 times bigger than the visible universe. That's 93 billion light-years times 250, which is 23 trillion light-years. Put it another way, the whole universe is to the observable universe as the sun is to the United States. So does that mean the universe has an edge? And if there is an edge, what lies beyond it? The universe, as far as astronomers can tell currently, may or may not have an edge. Instead, there exists only the edge of the observable universe. Like a spotlight shining from wherever you stand, illuminating the edge of what you can see but nothing beyond. An immense area covering 93 billion light-years of consistently expanding space that we are capable of observing from Earth using powerful telescopes. When we gaze at a distant galaxy millions of light-years away inside this circle, we are observing it as it was millions of years ago, not as it exists in the present time. The further we look, the further back in time we can see, until finally we encounter the earliest light that occurred just a few 100,000 years after the Big Bang. This is not a physical edge, but instead the afterglow of the Big Bang, known as the cosmic microwave background, the farthest point in the universe that we can observe from Earth. And yes, the universe could always indeed be infinite in size. In that case, the calculation of its size becomes pointless. By definition, there can be no shape assigned to an infinite object, as it lacks any boundary points that could be used in mathematical calculations. This infinite expanse would come as a sense of majesty and beauty that is beyond comprehension. Imagine the endless stars and galaxies, each one unique and full of its own secrets and wonders, stretching out into infinity. And the fact that the universe also continues to expand, creating new space and new possibilities for the future, only adds to the magic of its boundless nature. Whether you're an astronomer, a philosopher, or someone simply who appreciates the beauty of the cosmos, the infinite universe theory is an awe-inspiring wonder that will continue to captivate the imagination for generations to come. And it's a reminder that amidst the bustling chaos of our everyday lives, we are but a tiny speck in the vast expanse of the universe. So the next time you look up at the night sky and see the stars twinkling in the distance, take a moment to remember that you are but a tiny, fleeting spark in the grand cosmic drama, and embrace the infinite mystery and beauty of the universe. For it is in that infinite space that we truly find our place. Let's embark on a wondrous trip into the abyss and actually realize the true scale of the universe, starting from Earth. As we begin to zoom out, the Odyssey commences with our birthplace, the Earth, a planet that stands apart, being the only celestial body in the known cosmos that harbors life. Millions of diverse species flourish on its ever-changing terrain. However, none have altered its aspect as significantly as the human race. From this height, the impact of human civilization is palpable, with our man-made structures, highways, and agricultural fields likely to persist as evidence of our existence for centuries, if not millennia. Yet, as we soar higher, every aspect of who we are and what we have built begins to fade. From this vantage point, it becomes challenging to discern that we ever existed. Our entire history is rooted in this solitary blue sphere, a place where billions have lived, died, and where countless more will come into being. This is the world where it all started for us, the cradle of humanity. But now, we must leave all of this behind and travel further than any human being has ever traveled before, as our destination is quite literally the edge of the universe. Our first stop is the Moon, our closest celestial neighbor, and the only other celestial body where humans have set foot. Subsequently, we cross the orbits of other planets as we head towards the boundless void of interstellar space. Our Sun, the star that nourishes our seas, stirs our atmosphere, and provides energy to the growing plants that produce oxygen for life on Earth, becomes just one of billions. Many of the stars that dot our night sky can now be seen in their vivid glory, untainted by the Earth's atmosphere, like bright, colorful dots on a black canvas. This is just a tiny fraction of the Milky Way galaxy, where some of the stars possess exoplanets, some of which may possess the suitable conditions for life as we know it. Nonetheless, we cannot pause to explore these alien worlds, as we have a long journey ahead, and the Milky Way is incomprehensibly vast. Clouds of gas and dust, together with hundreds of billions of stars, planets, and moons, extend across an area that spans 100,000 light years, and concealed within its brilliant bulge lies a monster, a supermassive black hole. From this location, we can grasp the sheer magnitude of the galaxy that we call home, which, despite its enormity, is just a droplet in the ocean of galaxies that pervade the observable universe. Each of these shining points represents another galaxy, brimming with clouds of gas and dust, and billions of celestial bodies. Like the Milky Way, which is now just a faint speck in the distance, most of these galaxies harbor a supermassive black hole at their center, some of which are even merging in a cosmic dance of gravitational interaction. This awe-inspiring view reveals that the universe is not evenly distributed, with large, empty voids between dense clusters, connected in a magnificent cosmic web. This is just a tiny glimpse of the observable universe, a single page in a 13.8 billion year tome spread before us. The journey shows the incredible scale of the universe and the relative insignificance of our planet in the grand scheme of things. At this point, we might try to question ourselves, our existence. The truth is that our knowledge is limited, and essentially, we are cognizant of nothing. The delusion of having all the answers restricts our ability to embrace and contemplate the infinite possibilities of the universe. As we exist on this tiny speck of dirt floating aimlessly in the vast emptiness of space, it is remarkable that we have the capability to see as deeply and widely into the cosmos as we have. Nonetheless, our understanding remains minimal, and the reasons behind the occurrences in the universe are often beyond the grasp of our limited minds. So the next time something happens that doesn't go your way, just go with it. Just go with the flow. There's no point in resisting the universe. Life is not about having all the answers, but rather embracing and relishing the moments as they come. Our existence is not limited to that of an individual, but rather we are an integral part of the universe, a focal point where the cosmos is becoming aware of itself. From our limited perspective at this moment, being in our heads, we feel quite separate from the universe. But think about it this way. Every atom that comprises our being once originated from a star. And over billions of years, the universe evolved and changed to bring us into existence. That's how you were made, literally from star stuff. It took billions of years for the universe to evolve and change and create us. We're tiny, but we're also exceptionally special, as is everything in the cosmos. The universe is intelligent. It's not just a bunch of dumb matter floating around colliding haphazardly. One universal intelligence or one consciousness is what's guiding this whole thing, including you. We just feel like separate cells because that's how our limited minds work. As Neil deGrasse Tyson puts it, and I quote, "We're all connected to each other biologically, to the Earth chemically, to the rest of the universe atomically. Not only are we in the universe is in us. As we are the universe, it is our responsibility to treat each other with love, respect, and dignity. Our survival as a species and a planet depends on our unity, and I believe that we have the potential to persevere. Until then, the question of what lies beyond our observable universe can wait and remain one of the greatest mysteries of all time. Even with all the knowledge that we have gathered so far, we are still just scratching the surface of understanding the universe. And as we come to the end of our journey, exploring the biggest secrets of the cosmos, it's hard not to feel a sense of existential crisis. But this realization should not bring us down. Instead, it should inspire us to continue searching for answers and expanding our understanding of the universe. After all, the pursuit of knowledge is what makes us human. And our quest to uncover the secrets of the universe is a testament to our insatiable curiosity. So as we close this chapter, let us not forget the infinite possibilities and wonders that lie beyond our grasp, waiting to be discovered. The universe is a never-ending story, and we are merely a small part of it. Let us embrace the unknown. Let us never stop searching and exploring, for the biggest secrets of the universe are still waiting to be revealed.